Today we'll be talking about different types of waves and their characteristics. First, a wave is a disturbance that carries energy from one place to another through matter. Most waves, called mechanical waves, need a medium to travel through. Sound waves are the most common type of mechanical wave. The other type of wave are electromagnetic waves. They do not require a medium to travel. They can travel through the vacuum of outer space. Electromagnetic waves make up the entire electromagnetic spectrum. They are all the different frequencies and wavelengths of light seen here, from gamma rays all the way down to radio waves. Waves are caused by vibrations, which are transforming energy from one type into another, and that energy is then propagating outward from the source of the wave, like throwing a rock into a pond and seeing the waves spread outward from the center. Now there are two different ways that waves can travel through a medium. The first is called a transverse wave, whereas the wave is traveling right to left, the particles in that medium are vibrating up and down. So as the wave is traveling, the particles in it are vibrating perpendicular to the direction of wave travel, sort of like doing the wave at a sporting event. Another way waves can move is called a longitudinal wave. This is where the particles in the medium are vibrating parallel to the direction of wave travel. Sound waves are a particular example of longitudinal waves. We can demonstrate the difference between longitudinal and transverse wave motion by using a slinky. Now, in this example, the wave is going to move from the left to the right. With a longitudinal wave, we are pushing on the slinky, sending compressions through it towards the right. Whereas we have a transverse wave on the bottom, we are shaking the slinky up and down as the wave is traveling to the right. So the particles in a transverse wave are moving perpendicular to the direction that the wave is going. The last type of wave motion is a surface wave. It's basically the combination of a transverse and longitudinal wave motion, where the particles that are on the surface will travel in a circular motion, just like you were floating in the ocean. As the waves are coming by, they're picking you up, bringing you in towards the shore, bringing you back down, pulling you back out. You move in a circular motion. Next, we'll talk about the characteristics and parts of transverse and longitudinal waves. The first is amplitude. In a transverse wave, this is the distance between rest point and the peak of the wave. The higher the peak, the more energy the wave has. In a longitudinal wave, that amplitude is seen in the compression of the wave. How much the wave is compressed tells us how much energy is in that longitudinal wave. The wavelength of a wave is the distance between two consecutive parts of a wave. So it can be from crest to crest of a transverse wave or compression to compression of a longitudinal wave, whereas the distance in meters from one wave to another. The frequency of a wave measures how many waves pass per second. It is measured in hertz. The closer the waves are together, the smaller the wavelength, the higher the frequency of the wave. The period of a wave is measuring how long it takes one full wave to pass a certain point. It is basically the inverse of frequency. So the higher the frequency, the shorter the period. This is true because the wave speed is held constant through certain types of materials at certain temperatures. In general, sound waves gain speed as they enter more dense materials, whereas light waves do the opposite. They pick up speed as they enter less dense materials. We can calculate wave speed by basically doing distance over time. Wavelength is the distance divided by the period, or since frequency is 1 over period, we can figure it out by doing frequency times wavelength.